All right, we're going to get started, everybody. So it's the end of the day, and sugar and oxygen are in like high and then short supply. So we're actually going to have kind of a slightly truncated session with a little bit of talking from me and from Diana and from Ian. And then we're going to wrap up with hopefully some talking from you guys, assuming you're all government people. Does anybody here work with address data or GIS data? Okay, good. That'll make it much easier. So I'm going to do a really quick introduction to the Open Addresses project and why Code for America cares about it and why we think it's interesting. I'm Michael Magursky. I'm the Chief Technology Officer here at Code for America. Ian Deese, who is the founder of the Open Addresses project, is going to talk about the history of it and specifically how we think that governments, especially local governments, can help. Diana Shkolnikov, who's with MapZen in New York and San Francisco, is going to show how companies like MapZen, Mapbox, and others who work with address information can use projects like Open Addresses in order to ingest information from government sources so that geocoders used by regular people out on the real internet are actually being sourced by authoritative government data. And then all three of us are going to stick around because we hope to use this as an opportunity to talk to those of you who are thinking of maybe opening data like this, aren't really sure how best to go about it, to just kind of pester us with questions and turn it into a bit of a free-for-all. So I hope that's interesting. There's kind of two things about the Open Addresses project that make it interesting for Code for America. First is that parcels and addresses are really foundational data sets. You know, if you were at the talks this morning, you may have heard that Code for America has a few different kind of core focus areas that it works in. One of those is economic development, and one of the things we found as we've done work in economic development is that parcel data and address data tends to be a really core data set that links a lot of other things. So whenever governments do things like introduce the idea of, you know, special economic zones or opportunity areas, or work with tax incentives, or kind of do any one of these, you know, economic-y kind of things that governments like to do, so many times it's tied back to geography and location in the form of parcels and addresses. And one of the things we found as we've looked around the country is that addresses are kind of, you know, in some places very easy to come by and in other places very hard to come by. So it was kind of surprising to us as we've been working on addresses and parcels for the past year to see how uneven that coverage can be. I spoke to a friend who works in the federal government, and he sort of estimated that out of the, you know, 3,500 or so counties around the US, that about a third of them are, you know, fully out in the open with their data and happy to share it. Another third of them are very reticent to share it. Maybe you have to sue them in order to get it out. Maybe they have sort of other reasons why they think they might be able to recapture some economic value from that. And then the final third, he just figured we're too rural to even have turned it into digital information that could be shared in the first place. So there's kind of a wide variety of problems there, all the way from, you know, good data that doesn't want to be shared down to data that might not even really be data in the way that we understand it. You have a question? Or waiting for term limits to kick in. Excellent. And then the other thing that we find really interesting about, you know, Open Addresses as a project and why it's valuable to Code for America is that it helps us think about how to keep data out of these kind of cul-de-sacs that we often see. You know, one of the patterns that we've seen as we've advocated for open data over the years has been that, you know, a lot of times governments sort of almost think about it as a kind of a box to tick. So, you know, you buy, you know, some open data portal service from some vendor someplace, it becomes the centerpiece of a mayoral speech someplace, and then essentially it kind of goes there to die. You know, maybe it doesn't get updated. Maybe there isn't an ETL process that regularly feeds that data with current and up-to-date information. And so it very quickly kind of falls out of currency with the people who might need to use it most. A lot of times those people will know to Google search for things like, you know, kind of business or core terms about the data, but they might not know that an open data portal is the kind of place that they have to go to find it. So we're thinking about how do you get data kind of out into the world where people can find it and out of what we call these data cul-de-sacs. So Code for America has been working with Open Addresses to collect data from all around the world. Has anybody here not heard of Open Addresses? Okay, good, lots of hands. Lizzie, you're not telling the truth. Open Addresses is a project started by Ian Deese. It's only about 1.5 years old right now, I believe, but it comes out of work that Ian had been doing in the Openstreetmap community, and it looks specifically at the addressing problem. So for those of you not familiar with Openstreetmap, it's essentially a kind of wiki-style map of the world. And over the past, I want to say 11 years at this point, it's been collecting crowdsourced information all over the world focused on street-level data. Locations of post boxes, building outlines, street center lines, points for trees, basically anything that you might represent in a kind of Google Maps scale map of the world, OpenStreetMap attempts to collect. One of the big blind spots of OpenStreetMap has been addressing specifically. If you're looking at things that you can see with your own two eyes, those are very good data candidates for OpenStreetMap. You can go out and verify that a street has a certain name, or it's got a bike lane on it, or it's one-way versus two-way. These are all things that kind of lend themselves to crowdsourcing. In the case of addresses, there's like too many of them, they're too particulate, it's too hard to collect on an individual basis. And so in OpenStreetMap over the years, what we've seen is kind of patchy addressing. On my street in downtown Oakland, there is one address, which is mine. In parts of San Francisco, there's very complete addresses because people have actually gone through the work of importing that stuff, but it's patchy. And that's a really poor fit for the way that government authoritative data sources work. If you go to a county or a city website that publishes this stuff, typically you kind of want to see everything. You don't just want to see like the 10 addresses that like the hacker enthusiasts have decided to put in. You want to actually have some faith you're going to see all of it. So Open Addresses is a collection project that tries to deal with authoritative data sources specifically. And the other thing about Open Addresses is that we try to handle the weird parts. So one of the things that we found over the years at Code for America and talking to government officials who want to open source their data is there's kind of a lot of fear, uncertainty, and doubt about doing it right or doing it wrong. If we open this data, are we putting it in an incorrect format or a correct format? Are people going to be able to read it or don't? Is PDF enough? Is an Excel file open enough? All this kind of stuff. So what the Open Addresses project tries to do is to sort of shift that balance a little bit and basically say, if you've got an Esri Arc feature server someplace online, that is fine. If you're publishing, weird text files or CSVs, that's fine. If you've got zip files full of, shape output or geodatabase output from Arc products, that is completely fine. We're trying to meet people where they are, and we're focusing the energy of the Open Addresses community around essentially describing the data that they find and then sort of annotating it, saying, okay, there's this zip file, it's got a shape in it, that has 8 columns and 2 of them are relevant to us and we're going to map them. So it tries to make it kind of less of a producer problem to make this data consumable for companies like MapSend or Mapbox or others, and make it more something that a community of volunteers can do. Right now, as of this morning, we have about 208.8 million address points from 1,100 sources around the world. We just added Mexico, so that's what bumped us over 200 million this week. As you can see, it's patchy, but there's some areas of completeness. So, all of Poland is completely published together because that's all one data set that gets published on a voivodeship basis. Spain is complete. France is almost complete. UK, weirdly absent. The US is really interesting. It's kind of patchy because what we've seen in the US is that address publishing is really kind of a state and a county affair. And so, some counties in California will happily publish data while other ones will fight you tooth and nail and force you to sue them for it. In Montana, you've got both state and county publishing working there. So it's really kind of a patchwork of how the different officials and GIS folks in each of these places view their data. Yes?
Question, is this a map of parcels or addresses?
This is a map of addresses, yeah. We're thinking of parcels as kind of a secondary data set. So the first thought with parcels is, okay, now that we've got these address points, we can start looking back at those sources and seeing which of them also have parcel style information. But the kind of driving force behind Open Addresses, as we've been thinking about it as a project, is how do you get this stuff into geocoders, which these guys will talk about in a little while. So what we're hoping to see from governments that are interested in this kind of work is to open their data so that search companies like MapSend, Mapbox, Google, and others can actually find it and make some use out of it. If you know anything about how larger firms like Apple or Google do their work, you'll know that they have 3, 4, 5,000 employee teams that work on this stuff. They drive trucks around, they spend like enormous amounts of money collecting this kind of stuff. What we're hoping to do with open address is make this closer to the authoritative source, but also a little bit more ready for smaller, newer players in the market to be able to kind of do geocoding, do searches, do basic kind of address functionality that might otherwise be something only available via like a Navtech or a TeleAtlas data license. We're also sort of encouraging people to not have to host their own geocoder. Esri products will definitely let you host a geocoder, but a lot of times people might be sensitive about opening up their geocoders to the entire world because that might represent too many computing resources for them, for example. So what we're hoping is that in using a project like Open Addresses, it makes it possible to kind of spread that load around a little bit. So one municipality might choose to host its own geocoder, while another one might say, well, we don't have the resources to handle that, but we can definitely use our existing, let's say, Esri products to publish this information so it becomes consumable kind of upstream by somebody else. So we've got two folks that are going to talk to you more about this. Ian Deese is the founder of Open Addresses and also a longtime board member on the Openstreetmap project. And Diana Shkolnikov is the director of engineering of Maps and Search. Ian?
Hello. Sorry, my hands are all wet now. So Mike kind of touched on most of this, but I wanted to talk about why we are collecting address data in the first place. And Diana will talk about it in more detail later, including a really cool GIF. But addresses are a very important part of mapping because when a normal person, not one of the tech nerds, comes up to a map interface, they want to type in their address or their work address and not type in a latitude, longitude, or a what3 emoji or what 3 words code. They want to be able to type in an address that they know and be able to jump into a map that they understand, their local area, their business area. And so the process of converting that address into a latitude, longitude is geocoding. And for a long time, the only really great publicly available and usable geocoder is Google. A lot of people are shaking their heads at me. But so the goal here is to change that by making address data freely available and make it easier to improve and write your own geocoder. And that's exactly what's happening. So I looked around and saw that there was no existing open addresses data set. I looked at Openstreetmap, and in fact, I tried to improve it in Openstreetmap by importing a bunch of data. And as some of you might experience, there's a lot of people in Openstreetmap that aren't as excited about importing external data into Openstreetmap as I was. And so I did Chicago, and that kind of triggered a lot of bad feelings. And so I said, I've got all these other ideas for where I could pull in data. What should I do with it? I'll just keep a list. And I made a Google spreadsheet. I had some other friends add to it. And eventually it became a GitHub repo. And now there's some other software that's tacked onto it that Mike writes and helps with. But that's basically what Open Addresses became. There's some other projects that try to do this too. Openaddresses.org sits on a domain that I would love to have. But they're still trying to do their own thing. They are based out of Europe. They have not really done anything for about 5 or 6 years. But they have a similar sort of find authoritative data and collect it mentality. There's another project called Open Addresses UK that just recently kind of quieted down. They ran out of money, I think. And their idea was that in the UK, the address data set was sold to a public-private partnership. That means that the public can't really get access to it anymore. And so they decided that they wanted to ask everybody to type in their address. And it turns out that that is a really hard problem, and not many people did it. And they were also not really collecting any location information either. So they kind of quieted down. Recently, there's been a couple United States national level projects starting up. You might have seen a post on fedscoop.com about the National Address Database. That's a DOT project that is looking to do almost exactly what Open Addresses is doing. And in fact, they're trying to work with us to make that happen. Community Tiger is a project by the census to do a similar thing, but I don't think they're trying to be public about it. So, as Mike said, we are made up of 1,100 plus data sources. He actually looked at the number before writing it down. So he was able to say 1,101. But basically, like I said, our data set turned into a GitHub repo. There's a sources directory that's broken down into, how do I scroll on this thing? That's broken down into countries and into second level admin, like New Hampshire. And then inside of there are JSON files that have information about where the data is coming from and a general coverage area. Most of the time this has some kind of information that we could use to draw that map that Mike was showing. Alongside that is some software to do the translation from the source into our data format. And this runs on a EC2 machine, on an Amazon Web Services machine, and it actually does all the downloading, all the processing, and spits out the resulting data that you can then download on our website, openaddresses.io. And I think Mike showed this map, not this one, sorry. So this is a map of every address. Sorry, I needed two hands for that. But this is a dot map, basically, of every address that's in our file. And it gives a pretty good idea of the coverage. I live in Virginia, so that's why I was tending that direction. But in the US, we do a pretty good job. Gives you a pretty good idea of what we've got in addition to that map that Mike was showing. Did I just go to? Yes, there we go. So the next step for us, as we mentioned before, we're going to try and work on parcel information. A lot of the sources that we're pulling from already have parcels, or we're pulling from the parcels already, or there's parcels alongside the addresses. There's been a lot of interest in having a feedback mechanism so that if a geocoding server or service had a customer that reports some kind of error in the data, we can take that in from the service and then filter it back to the source that it came from if they're interested. And then we'd also like to make it so that we can use this project as a way to promote open data and say, look, all these people are already doing this. That means it's cool. And we also need to start talking with people like you who might not have their data open yet, and we could help facilitate that. So next is Diana, who's going to talk about an application for this data.
Thank you. Hello. So I work at MapZen, and I'm head of the search team. And we're working on the problem of geocoding against addresses and open data. And we're predominantly or exclusively running on top of open data. So all of these data sets like OSM, open addresses, are really important to us in order to make our tools work. Basically, if you have all this data, it's awesome. But if you have no tools on top of this data, then the data doesn't really make a lot of sense, right? It's not adding value. So as an agency, if you expose that data, you would hope that there's a whole slew of customers that are just waiting to all of a sudden be able to use it. And we make that possible with our search engine. So geocoding, I think the other guys have already alluded to what it is. It's basically the process of converting text into a latitude, longitude, and then reverse geocoding is the opposite. You take a latitude, longitude, and you convert it into an address that might be nearby that location. And some of the examples, for those of you that are asking where would you even use this or why would you need this, Airbnb is a good example. There's a lot of these location-driven services that use this type of functionality. So you'd start typing your, the thing you're interested in, and it finds this for you. Another one is pre-filling billing addresses. So like things where you wouldn't even think you're geocoding, but you're actually doing that. Or like a Google invite. Sorry, it's a little hard to see. But if you start to type in the where box, it like automatically wants to find you an address, which is cool. And obviously the apps that you use all the time, like Meetup and Evite, just other examples of this kind of thing. And then I wanted to talk about what are the key functionality, what is the key functionality that a geocoder is expected to provide. So clearly you should be able to type in an address and it should give you a latitude, longitude. You should be able to type in the name of like a city or a state or a country and have that show up with the geometries. You should be able to get autocomplete. That's a feature that we support. So as you start typing, we start suggesting things that you might be looking for to save you time. You should be able to search for things by category. So you should say like an Italian restaurant in my neighborhood or near me. You should be able to do it in different languages. That's also like a really big problem for geocoders is localization. And we're focused on the US addresses, but as a geocoding service, we also need to think about the world. And if people are searching from different countries, they might not be searching in English. And then the reverse geocode that I've talked about, which is your location, and we want to suggest like all the things that are near you and where you might be. Think like Foursquare check-in type of functionality. And the hardest problem is like natural language processing, and that's something that a lot of geocoders aspire to. And basically the idea of like you say something that is human speak, like bagel shop around the corner, and the geocoder magically knows what around the corner means and understands the category that you're asking for. And then some other things like batch processing, which is important for the types of data sets that you guys are working with, where you have a lot of data. So it's a nice feature if a geocoder can support it, pagination and formatting results in different ways. And then you are what you eat, as your mom says. So basically what data you consume into a geocoder has a high correlation to the quality of the results that you're going to see on the other side. Just a little comic relief. If you eat bad data, basically, you're not going to get good results in your Oh, it went away. You guys saw that. So just to talk about the data that we consume as part of our service, we are, like I said, we're exclusively built on top of open data because we believe that open data will win over proprietary in the end because the community is there to support it. The government agencies are exposing their data more and more, and people are seeing the value in open data, and therefore it's getting better. And as the tools get better, the data will also get better because people are driven to use it more, and so they want to make it as good as it can be. So these are the data sets that we use: Openstreetmap, open addresses, obviously a big one for us, and geonames. And then QuatraShapes is down here. QuatraShapes provides the admin areas, so administrative regions like countries, states. It has the shapes for all of that data. And what we do is enrich the data that we get from these data sets and make sure that it all has the hierarchies. So like in open addresses, a lot of times, the government data doesn't have the city and state because it's assumed, right? But for someone that's consuming that data, it's important to see that entire hierarchy in the data itself. And so we update the data, enrich it with all of that information, and then make that available as part of the search result. And then I was going to show you guys a little bit of hands-on stuff. So if you would like to use the service, we're actually really excited because we're launching the actual API service today. So as of this morning, you're now able to get a developer key on our website and start using the service to test it out or to try to embed it into your projects. There are documentation files on GitHub that you could follow along with. There's some blog posts on the history of the service and what we're trying to do and our mission. So we're really excited if you want to sorry. Oh, that was so fast. So if you go to developers, mapzen.com/developers, you can sign up for a key. I don't know how many of you have GitHub accounts, but right now it's required that you have a GitHub account. But those are free and easy to acquire. So you just grab a GitHub account and then get a developer key. And then once you have that, oh, why is it doing that? I'm sorry. I don't know what's going on. Now it's going to do this again. Hold on.
Oh no.
Okay, we're just going to stop here. So I just went and found a few film location addresses just to show you guys the kind of results you can expect to get. So like this was the address where they filmed the sleepover scene from Greece. But you could see, you type in the address and the data comes up. But I'm going to show you what it actually looks like. This might not look great because this machine doesn't have a way to like show the GeoJSON nicely. So a little bit of stunt demoing here. Come on, click. Pretty print. Pretty JSON. So the data comes back in pure GeoJSON, and it has information about what the query looked like, but then also you can see, oh, you can't see. Control plus. Yes, it works here too. So you can basically, what you get is a list of results, and you could see the very first result. I'm gonna use the laser pointer. You could see that it tells you that the layer is address. The source is OA, which stands for open addresses. But if you weren't specific and called out the fact that you only wanted to use open addresses, you would get data from OSM and other sources, and it would be reflected in this parameter. And then we have the name, which is the combination of like the street, basically the street address, house number. So we further break down the address into these different parts, so you can do what you want with that data. The alpha code for the country, the actual name for the country, the region, which in our case is the state, county, locality. In some areas, we even give you neighborhood data, which is actually hard to come by, as some of you might know. And then where we have it, you might get a zip code. So there's postal code over there. And then we also create this nifty label. So if you had a front-end application that wanted to show that on the map and then have a label next to it, or if you wanted to show a list of results, you would just grab this label. And obviously the geometry over here has the coordinates, which is where that's the money shot right there. And then if you keep scrolling, you could see that the results still resemble that address, but are maybe suggestions of things that are slightly different. So it's a nice feature. You say like, I want 4527 or 4526, but then we show you that first, but then we also say, hey, if you're interested, there's also this 4527 and 4528, and maybe you misspelled Avenue or Kingswell. So like, we're gonna show you these other things that match similarly. And that's a nice feature because sometimes people mistype things. So let's get us back to presentation. But because it just keeps scrolling off. The idea is that there were a few more addresses in different parts of the world, and wherever the data in open addresses supports it, we would be able to expose it. And then I also wanted to show that it basically, if you have all this data, you can't really attest to the quality of the data unless you have tools like this to search for. So, for example, when I was trying to find compelling demo things, I just did, in the query, I just said, let me see anything that has Main Street in it. And wait for it, pretty print. Wait, I went back. All right. Okay, so if you scroll, the first item that came up for me was this guy, and he has question marks in the house number. And I feel like that's the kind of thing you would never find unless you had tools like this to expose it, right? So if people aren't searching the data, then there are possibilities that it's wrong and that it's incorrectly written, or that the house number could be in the street column for whatever reason. You know, the data is not perfect, but this allows people to see it and to feed the corrections back into the source, and therefore create a cycle for bettering the data, and therefore making the tools better, and so on and so forth. So that's what we have. And then, like Mike was saying, we want to kind of open it up to you guys to ask a lot of questions and you know, create a dialogue about, like, how can we expose more data? Do you have any questions about the tools that are sitting on top of this data? Any of that, please ask us questions.
So 3 of us are hanging out for the next half hour. So
Free for all.
Yes.
How do you, I know you've probably got more address data there than, say, that's in Openstreetmap right now, right? How does your licensing compare to Openstreetmaps, and is there a way for them to go back and forth?
yeah, ooh, licensing is a good question. So the question was, whoa, how does the licensing compare to OpenStreetMap? So I think one of the things, I'm going to get out of the feedback zone. This is better. One of the things that Ian, I think, didn't mention was that OpenStreetMap has a license, which is called the ODBL, or Open Database License. And this has kind of traditionally been a bit of a roadblock for people that want to use the OpenStreetMap data elsewhere. Essentially, what the ODBL says is you're allowed to use the data for whatever purpose, but you have to take any substantial derived work that you make with that data and license it also under ODBL. So, you know, in the absence of a lot of legal precedent around this stuff, it sort of looks like a bit of a frightening thing to a lot of people that might want to, say, you know, present that data on a map on a commercial service and are then wondering if their entire commercial service is now covered by this sort of so-called viral data or viral license. So what we're doing with open addresses is right now we're basically just saying, like, all this data is sort of open enough that you can use it and do something with it. But we've got a fairly active discussion right now in the repository where we're basically talking through, like, what does it mean to start to classify the licenses that we found. So for example, all the French data has some kind of variant of that share-alike attached to it. Most of the US data doesn't really seem to care particularly. And then a lot of other countries have sort of other, like, you know, kind of question marks attached to that. So we're looking at the Creative Commons project, which, for those of you who aren't familiar with it, it's meant for copyright and creative works. And they have kind of a series of license properties or flags attached to the different licenses you can choose. So there's things like, you know, yes, no, allowed to create derived works. Yes, no, you have to attribute where you got the data from. Yes, no, you're allowed to use this thing for commercial projects. So we're basically looking to kind of import a bunch of those flags into open addresses and go through, you know, in this kind of crowdsourcey, like, lengthy and time-consuming way, all those different licenses and figure out, like, which of these things require a share-alike clause, which of these things require you to, you know, only make non-commercial stuff with it. And then we're basically looking to take the big download that we currently have and start splitting it up into separately licensed downloads. So it's like, here's all the world's data that you can do whatever the heck you want with. And then here is all the world's data that requires attribution, and et cetera. So we're kind of still trying to figure out, like, what those actual flags are, because, you know, there's definitely some weirdness around just borrowing terminology from a whole other legal domain and sticking it on this one, as you might imagine. But we're kind of thinking that that's the direction that we want to take with it.
So places that you get it mostly all from are fairly self-contained, especially if they don't have license restrictions. Places that you have really spotty data, what's the future next 3, 4, 5 years? Those are really incomplete. They're not really going to be very useful, right?
Yes, the question was, what do we do about places that we have spotty data for? So the US is a great example of that. Like, there's no nationwide address data set for the US, so it tends to be at best counties or states. I think the future there is that we're hoping to use kind of venues like this to talk to the people that are actually authoritative owners of that data and try to figure out what kind of blockage exists, either legal or technical or otherwise, that's preventing that stuff from getting out in the open, and just sort of talking through the problem here. So the theory with open addresses, and the reason why CFA is interested in it, is, one, it kind of shifts the conversation away from, you know, you should open data because it's a good idea, into kind of a less polemic place and a little bit more of a functional, like, you should open data because it's actually useful to people. But there's also kind of a flip side to that, which is the actual ease of doing it. Like, we're trying to approach it from this angle of actually doing a lot of the code work on our end, so that there's less discussions around, like, what is the right or wrong format, or what is the right or wrong data standard to publish this stuff in. So I think what we're hoping to get out of that is, I think, what did you call it? The like overflowing bucket, or the
Open data bucket.
Yeah.
The bottom of the bucket.
Yeah. So that we think that there's still a lot of stuff out there that's openable, and what we're hoping to do is to kind of get rid of as many problems and obstacles to doing this as possible. So once you actually get to the place where a county is just sort of folding their arms and saying, no, we want, $200,000 for this DVD or something, then that you can kind of get to that conversation earlier. It's harder to hide weird license and financial stuff when the technical things are already sort of being handled for you, essentially, by a developer community.
So just as a quick follow-up comment for the United States, if you were to publish a side map that classified county data policies in very clear ways, that would probably be very useful to those in other venues working to advocate for parcel data.
Yeah, for sure.
It'd be interesting, like, what happens if you had, like, every single county in the entire U.S. had an address in GitHub, but it was, like, not shared. So people could then dive in and, like, I'll take that issue.
Oh, interesting. So like individual counties would basically be running their data sets in this way?
Or just you can see, like, there's a county here, and the JSON's empty.
Yeah, I feel like I'm hogging the mic.
Like a help wanted issue where people could contribute.
So we kind of did that. Whoa, this one's way louder. So we kind of did that, and it made it so that it was really difficult to track down and keep track of what was available, because so many of them were open and in the need help flag state. One of the things we ended up creating was kind of falling back to the spreadsheet that I started with way at the beginning. And so there's a spreadsheet of all the counties in the US and whether or not there's a source for them and whether or not we've found any data for them. And so that's a pretty good way of a really fast overview, because you can filter that pretty quickly. And so we kind of have that. It's just not very approachable for folks who are at a county level, that that kind of technical level.
So I work for a local jurisdiction that actually just started kind of an ad hoc effort to actually create a good data set for addresses. I'm not going to say what city I work for, but we...
What does it rhyme with?
So we do not... Oh my God. So we don't have... so there's discussion, like, Public Works has their data, planning has their data, the fire department has their data, and they are not all the same, and they're not always updated in the same, and so we're starting this endeavor to try to fix that. And so I'm really fascinated by this idea, but you're talking about relying on municipalities giving you that data, and I'm thinking, oh shit, like, I don't know that what we have to offer is like the best sorts of data. So like, how do you foresee what you're doing in like almost working backwards with cities to try to make sure that what we are providing to you is good?
Yeah, that's a really great question. So for the recording, the question is, how do you work with cities and municipalities, I guess authorities, to make sure that the data is good? One of the patterns that we've seen in the Openstreetmap universe, I think Laren Dalby, who used to be the GIO of the state of Arkansas, was a really early proponent of this. At least, I think, where I met you at the first OSM US conference was also where I met him. And his big interest, he basically oversaw all the counties that were publishing their street center lines. And he was sort of hungry for a feedback file coming from Openstreetmap showing where changes were happening. And his theory was, I can always send some county guy to go resurvey a couple of streets. Like, I want to be the source of the authority, but I really want a sort of signal telling me where potentially our data might be out of date. So if he starts seeing a bunch of activity in a given neighborhood, that might be a sign to him that some developer has just built a new subdivision there and it needs to be mapped. And that allows him to kind of prioritize his work. So I think we're still pretty far away from kind of closing that loop. But we're talking to a lot of folks, CFPB and a few other places that are thinking also in terms of this kind of feedback model. I think, Ian, you kind of alluded to it as well.
Yeah, I think the goal is to have, so maybe in one of the sources here. So if you see this GID here, like a global ID, the goal here would be to have some way of taking that number, that string there, and passing that back. Like if that looks wrong, it has question marks in it, not a number. You could submit a change back to MapZen, who would then flow that back up to open addresses, who would then flow that back to West Virginia, and tell them that this address is wrong. And so, or at least this address has been flagged as being wrong by 20 people or whatever. And so that would be a signal to West Virginia that maybe they should go fix that data point if they want to. And I think one of the goals here is that open addresses is trying to stay as close to authoritative as possible. And so we would probably hang on to, the thought is that we would hang on to that change that was suggested and apply it to our data set that gets consumed from the West Virginia data set and merge them together, and that would be what MapZen gets the next week, for example. And then hopefully eventually West Virginia also incorporates that change, and the merge doesn't have to happen anymore. It would already be in the source.
Yeah, one of the things that we've seen in some but not other open data sets like this, and I think you alluded to it at the beginning of your question, which is that, you know, fire has one data set and, I don't know, tax assessor has a different data set. I think I view it as sort of a sign of maturity of open data when there's permanently and basically permanent and stable identifiers attached to things. So if a place publishes an address file and says, you know, this is address number XYZ123, and it's going to stay address number XYZ123, that ends up being the hook from, you know, open addresses through to a geocoder like MapZen's all the way back, if you can actually keep that ID stable. And that's definitely kind of a maturity metric, I think, of open data. Like step one is just get it the hell out there. And then step two is, okay, what do we want feedback? Like, well, we have to provide some kind of hook for that feedback, and it has to be an identifier of some kind.
I do also want to point out that having different locations for different addresses is something that the National Address Database folks, the DOT, are really interested in, because UPS wants to deliver to one place, the U.S. Postal Service wants to deliver to another place for an address, the fire department needs to respond to a different spot. Maybe they need to respond to, there's 4 different buildings on a campus or whatever, and they all have the same address. And so I don't know if we need to support that, but at some point, some address data set needs to be able to support having multiple locations for a single address. And that's something to think about in the future, too.
Yeah, I would say for that, like if the data is propagated into your data set, you know, like this came from the fire station or such a source, then we could easily expose that as one of the parameters that you could search by. So let's say you are the fire station, you can just add that as a parameter in your search query, and then you can just get only the data that corresponds to what you're looking for.
Question here?
I was curious, I think you guys do this, but like she's mentioning the fire department, do you, if addresses are written differently, do you resolve them to the same thing? Because I was working on a parcel property thing, and then we had some weatherization data, but the addresses would look different, just slightly, like have a comma or something. Is there a way to do a resolve so that I know all 3 things are the same?
So right now, the project doesn't do that. I imagine that MapZen does when they consume the data. So for example, if we look at, I don't have it. We have both.
UPS or the post office kind of does it when you type in something, they come back as standard.
Right. There are certain geocoders out there that are not free, and you basically could use them to normalize all of the addresses to, you can normalize all your addresses using those particular geocoders. They have to be like certified by the post office authoritative, organization, and they say like this will result in a proper post office supported address. So you could use that. But there are very few of them, and it's hard to get that certification. We're working on a project called LibPostal, which is going to be a library that normalizes the addresses in a similar way. It's something that's going to come online relatively soon, like within the next couple months. But that we're excited about that because there's potential for that to be like really close to what like the postal code, the post office resolution looks like. And then we also do like a dedupe process where we check if within that data set there's already something that looks like that, because sometimes it's the same address written in different ways. So once we normalize it, all those addresses look the same, and then we're able to compare them and not show duplicates. And so we've done that.
So right now, you normalize some point path with the fire department and something from the utility. I can say they're the same thing.
Yeah. So it wouldn't happen on the data level because they're, like Ian was saying, they're trying to stay true to the authoritative source and not change it too much, right? But at the ingestion level where MapZen will take the data and import it into our data set, at that point, we're able to do all of this massaging and make the data look clean on the way out. Like I was talking about, adding all of the additional hierarchy to it, as well as normalizing and deduping. Mm-hmm.
So I brought up the map here because if you see Virginia here is orange because it failed to download this one time. But the important part is that there's other green blobs in there, and those are counties that are overlapping existing Virginia data. So in our data set, there's probably overlapping address points. Right now, if you download the Virginia file, there are going to be 2 rows for my house, for example. But MapZen would dedupe those, basically.
Yeah, back there.
Thanks.
Girl talk right there.
I'm glad we have some support here. We don't support it right now, but it is on the roadmap to actually dive into that. Yeah, it's something that we get asked quite a bit, but because we're trying to create something that serves the entire world, the intersections is kind of something that like we've come accustomed, we've grown accustomed to in like New York and like areas where we speak intersections, but it's not necessarily a feature that is like interesting to people across the world. But it is something in our roadmap, and it's a hard problem, as you've mentioned, but we'll get there. Thank you.
So for a project like Open Addresses, I'm curious because there is no canonical data set that we're trying to create here. So how do you approach progress, or how do you measure the progress of coverage besides just a number? I was wondering how you approach that, or maybe try to slice that.
So the question is about progress and completeness. Just look at our graph or a picture. I think Tom, one of our teammates, was doing a graph that compared population and the number of addresses, and came up with some almost linear similarity correlation. And I think he was planning on using that to kind of make a guess. We don't have a good answer for that yet, but there's some thought about it. If you kind of overlay this kind of map, our completeness map, with population density, we have most of the big areas of the U.S., mostly because open data kind of seems to follow populated areas. And so we have a pretty good coverage of the population of the United States, but a lot of the interesting stuff that happens with geocoding and this kind of data is off in the rural areas, and so it would be really nice to be able to make that whole map green. So that's what we're shooting for.
Yeah, for what it's worth, the number that, this is Tom Lee, who works at Mapbox and used to be CTO at the Sunlight Foundation. I think the number he found was that it looked like for the areas that we had coverage for, there was about a 2-to-1 like human to address ratio. So we just kind of did the back of the envelope and found out that we have some, 5 to 10% of what we think is the number of addresses in the world based on 7 billion people. But obviously, there's huge chunks of the world that just don't have addresses. Or, an address there is sort of kind of this procedural, go to the end of the road and then a mile further, and that will allow you to deliver your letter. So there's, you know, concepts like postcode. There's, I think, the same way that it follows urban areas, it kind of follows like advanced, what's the term? Weird places, Western, educated, industrialized, rich, and democratic. So it covers the weird places, basically.
So I had a question. It sounds like you have a stated goal of getting source data directly from mostly government bodies. So are you not interested in sort of what I've noticed some of the OpenStreetMap approach, which is like boots on the ground, you walk around and, you know, say this address is from something Main Street. Is that kind of out of the question, or would that be an interim piece until you got authority data?
So the question is, can we crowdsource this? And I think in one of the slides that I was using in a different presentation, I kind of made the bold statement that addresses aren't crowdsourceable. I think, Mike, you touched on this before with OpenStreetMap, but that deep kind of data, the stuff that isn't really always visible on a map, unless you zoom really far in, is the kind of data that's going to be really hard to get a complete coverage on. And especially with addresses, you need complete coverage for it to be useful. And so if you pay 20 people to go map New York City for a day, you're going to get 1/100th of the city, and it's not going to be very useful. I guess if you keep adding on to that, it might eventually work. But I think the way forward with the way that we called it at the National Address Database Summit was the have-nots. The counties that don't have address data at all, public or private, is to find funding to pay somebody to methodically do it and not necessarily ask a bunch of normal people to go collect addresses. I would love to have that be the case, that a bunch of normal people would be willing to go around and write down addresses, but I don't think that there's a way to do that right now that would make a lot of sense for all that gray area.
Yeah, one of the things that the OpenStreetMap project uses as kind of a rubric for what should be mapped is basically what's visually verifiable by somebody else in that spot. So like administrative boundaries, which you can't actually see, are a really problematic thing for OpenStreetMap, as you might imagine, in contrast to, like, you know, there's definitely a fence here, there's definitely a street here, there's definitely a gate here. That's something that anybody could agree on. Addresses, I think, kind of fall into the first category, where like you might be looking at a building and you're like, well, does every floor have an address? Like, is there just one big address for the whole building? It's sort of not immediately apparent, which means you actually have to start to touch on the kinds of places that do see that stuff, and that would be like a tax assessor or a fire department, or, you know, somebody who's actually like, no, I need a spreadsheet of all these addresses in order to be able to, you know, pull somebody out of the building or take their money, basically.
And that's a good point. One of the things, especially in the U.S., that's driving the National Address Database thing is that a lot of local governments are getting money to implement E911 stuff. Basically, the local government is saying, or is getting money to say where everybody is, and they want to be able to use that when a cell phone calls up, so they can direct somebody, direct a first responder to a person in need. And that's where a lot of these address points are coming from, is the federal government sprinkling money down from above to get that E911 stuff happening. Yeah.
What about neighborhoods? What's the discussion on getting that? Because, you know, on the civic engagement projects, oftentimes you want to look at the data by neighborhood, because that also, some cases, that city council overlap. In other cases, it's just like the cultural, meaningful way that people want to look at it.
Yeah, neighborhoods are really contentious and are a hard data set to get your hands on. And MapZen is actually working on a gazetteer, which is a collection of data that is like the shape files. And it started with Quattro shapes and then getting a bunch of other data sources together into an authoritative source where we kind of make decisions on where things are right and wrong, and, you know, kind of opinionated about the data. This is a project that's already in GitHub, and you can keep, because everything we do is open source, you could already check it out now. It's called Who's On First. And it has neighborhood data. who's on first. If you, it's a quirky name, but basically the reason that it's that is because administrative data is confusing and people often like argue about it, and that who's on first skit, if you recall, was all about confusion. So I think that was the idea there. But basically you could go to who's on first off of mapzen.com and check out the data, and that has neighborhood data, and we plan to continue to make that better and source it. Right now it's coming from QuatraShapes primarily, but there are other sources that we're pulling in. And as people go in, and we're going to create tools that allow people to edit that. So you could say, I think the neighborhood ends here. And then we would basically allow for all of those to exist under one ID. So you could look up all of them and say, well, you know, which one is kind of like the one that makes the most sense to me, or the one that overlaps, you know, all of these are like the intersection of them, or the union of them, whatever, you know. So you can make decisions on the data. Yeah, so we're working on that. If you wanted to stop by our table to check that out later, we're in the tech fair, and we could talk about the who's on first efforts.
Can you talk about parcels?
Parcels are totally awesome.
I have a bunch of things I could ask, but maybe I just want to talk about it in context of all this.
Yeah, I'm trying to figure out where to start. We actually, Code for America's interest in open addresses started as Code for America's interested in parcels. So we were looking at parcels and we were like, we should make a data standard. Last October, we convened a whole bunch of people, including like Avi Bender, I think, who's the CTO of the census, Nancy von Meyer, who is like, apparently knows all the things about all the parcels, Ian and a whole bunch of other folks, and just sort of tried to kind of talk around this problem and see if there was some kind of opportunity there. And I think the first thing that we learned about the parcel data standard issue was that the world is not lacking in parcel data standards. It started to look like one of those things where, you know, there's 15 competing standards, and so we're going to charge in on our white horse and do the 16th one. Not the super smartest way to approach it. So open addresses kind of became a little bit of a shim to think about this, to basically say, you know, there's a reason, there's kind of a whole bunch of intersecting and aligned reasons to collect this stuff, and it all seems to kind of travel together. So some of the sources that are in open addresses, California ones in particular at the county level, I just happen to be most familiar with those, tend to be parcel data sources. So they'll have the situs address in them, and we just take a centroid and publish that. But we're sitting there on top of all of this polygon data as well, and tracking the fact that it's polygons along the way. So one of the kind of future plans for the data set is, okay, as we start to get this address coverage, we're going to be looking deeper into the kind of back catalog of what we've already got and see what in there looks like it's a parcel, basically what's a polygon. So in order to get there, we're starting to do things like, you know, beyond just like the street number and the house number and the postcode, mapping to see whether there's an identifier, like a unique identifier in the data set, because that tends to be something like an APN or a parcel number. Like I said, there's a lot of kind of, we're trying to take advantage of a lot of aligned, you know, economic and other interests. So like, you know, MapZen wants to build a geocoder that needs the addresses. We're interested in the economic sort of focus area development interests that are connected to things like addresses and parcels, and governments tend to be really good at collecting parcels and not always so good at sharing them. So we're kind of trying to figure out, like, how do you get all these interests basically kind of rowing in the same direction for a little while. But you sound like you have something to offer.
We've just dealt with it at a local level, and it seems like out of maybe most data sets you can think of, parcels in a lot of ways, especially if you attach property values, tend to be more tightly held.
Mm-hmm.
And I know that I was talking to Liz Diamond over there about Santa Clara, I think, had a legal challenge to opening up the parcel data, and that proceeded. So I don't know if that might be a precedent and something that could be used in other areas.
Yeah, I think Santa Clara and Orange County, actually Larry knows a lot about this.
What got opened up was the ability to get the geometry and the APN, not all the other attributes. In California, the assessors are allowed to charge whatever they want for all the other attributes. So the fight has been there in Orange County over just access to the geometry. And it's still not a clear win.
Parcels can be much more policy, financial issue than a technology issue with parcels is actually easier.
Mm-hmm.
But financially, it's the cash cow, received cash cow of these agencies. So you can unlock, you can validate through addresses the value, but more viscerally say you can make more money through tax revenue than you do selling it by making it open. That would help the parcels.
There's also an enormous issue in California with elected officials and first responders, and there's a state law that prevents you from revealing their addresses, so names get to be very complicated to try to expose, and that offers all sorts of weird complexity. I was going to also ask, though, that parcels and therefore your address points are notoriously accurate in rural areas. Any general strategy? That's just a source problem, right?
Yeah, I think it's sort of that last third of like, it's in a county office on a dusty old piece of paper somewhere kind of stuff.
Yeah, but that's the kind of thing that once the tools are there to use that data, then people can start to bring that to the attention of the source, and then we can make that better. Otherwise, it's just kind of sitting there, like you said, no one really knows what's wrong with it. Well, sure, unless you're trying to navigate to that person's house and he's having a party and like everyone shows up at someone else's house, then he probably cares.
They have guns out there.
Right.
Yeah, actually, Andrew mentioned the kind of economic stuff as well. This does actually remind me again of Laren Dalby, the Arkansas guy. One of his big rationales when talking about aggressively opening up all of Arkansas's street center line data was, he was thinking of it as basically an economic development opportunity. He's in the South. There's a lot of foreign car companies that are looking around the South to build, giant factories and bring tons of jobs. And his rationale was basically twofold. He's like, look, if Toyota is going to, if they're trying to figure out where to build a plant, I want to make it as easy as humanly possible for them to learn as much as they can about a place like Arkansas, so that they never feel like they have to go like hunting or digging or paying for this stuff, but so that it's just like kind of ready information for them. His other big point was really related to the E911 point. I actually didn't realize this, but he was saying that there was something called the new Madrid Earthquake, which is expected to come again at some point in the next, 30, 50, 100 years or something. Colossal, crazy, and Arkansas is like the least ready state in terms of, emergency personnel and other kind of metrics to deal with this stuff. So he's like, I just need this data out there so that when something like this strikes, we're not stuck in the same place that, Haiti was when the earthquake happened, where the building that has all the maps gets flattened and you essentially have to fly in nerds from America to like remap everything.
Do you know if the E911 funding has any requirement for sharing that data publicly?
I don't think it does. Yeah, and I mean it usually gets shared, but I don't think it's a requirement.
Yeah, we are just over the half hour, I think. So I'm actually really enjoying this, and I'm happy to stick around, but I don't want to feel like I'm keeping you guys in here. So I'm just going to say thank you.
Yeah, thank you.
And we'll hang out for a few minutes.